Good afternoon, my YouTube viewers. It is Crystal here. I'm just here this afternoon because I wanted to give you a code review. This code review is on a Kaggle community competition, and the data set is called Strike the Balance. And I'm not sure exactly what it was because it says decipher the name and it was a classification problem, but when I got to the data set it was all floats primarily, and because it was all floats primarily I wasn't sure exactly what the name business was all about. But we'll go ahead and go through the code review as to what I did, and then that way you can see what I did and how I worked through it. So I wrote the program in Kaggle's free online Jupyter notebook that's stored in my account, but what I will do is I will give you a copy of the Jupyter notebook in the description box down below, so you can look at the Jupyter notebook if you like, and you can look at my code. I got a 91% using this methodology, which isn't too bad. I only tried random forest classifier one time. Some people scored better than me, but I did use random forest classifier, and most of the people don't make their notebooks public, and since they don't make their notebooks public, it's a little bit difficult for me to look at other people's notebooks to see if there's any way I can improve my score. But I made my notebook public for you to look at. So the problem statement is decipher name, and it's a classification problem. So that's what we're going to do. But all it is just numbers. So I don't know why they said decipher a name, but they did. And then after we go through the problem statement, we import the libraries. So we're going to import NumPy as NP, so that you're going to create NumPy arrays and perform numeric computations. We're going to import Pandas as PD, which creates data frames and processes data. We're going to import OS, which goes into the operating system, and it will retrieve the files that we need. We're going to import sklearn, which provides machine learning functionality. We're going to import SciPy, which performs statistical functionality. We're going to import matplotlib.pyplot as PLT to use to visualize the data. And we're going to import Seaborn as SNS to statistically visualize the data. So after we have imported the libraries that we need, what we're going to do is we're going to use OS to go in and retrieve the files. So we retrieve sample submission IM, we retrieve data2, and test data. So after and these are all CSV files, by the way. So after we have retrieved the files that we're going to need to execute the program, we use Pandas to read the CSV files and convert them to data frames. So data2 was converted to a train data frame, test data was converted to a test data frame, and sample submission IM was converted to a submission data frame. And then so you can look at the train data set and you can see it's all numbers. So I'm not sure exactly what this is all about. I'm not sure if the data had been previously standardized. I'm not sure if it previously had been standardized and that's just standardized data. That could be what the problem is. So if I wanted to, I could go back and make another Jupyter notebook and not standardize the data, and on the assumption that the data already had been standardized, and see if that improves the score. Now that's something I could do. Then we look at train. You can see that all of the columns are floats except for the last column, which is Y, which is an object. We check for any null values. Fortunately, we don't have any null values, so we don't have anything to deal with. We look at the test file. The test file has an ID column which is not present in the train file. And then other than that, it's identical to the train file except for the fact that it doesn't have a Y column either. We check for any null values in the test column, and we see we haven't got any null values. So we're going to drop the ID column from the test file, and the reason why is because in Pandas, all of the rows are automatically indexed anyway, so you don't need it. And then we're going to check the submission file, and so this is Y, and it wants to have, this is what the Kaggle wants to see when you submit your work. So we're going to analyze Y. Y is your target. So we're going to pop Y out of the train file and make a histogram from it. So this is your histogram, and you can see B is the most frequently occurring value, followed by A, and then C, and then D, and then E. So we print our unique values. So you can see that there's 5 unique values, A, B, C, D, E. Now what we're going to do is we're going to use SciPy to perform the Kolmogorov-Smirnov 2-sample test to see if the columns in the train set are from the same distribution as the test set, and you can see that XO is not drawn from the same distribution, and so since it's not drawn from the same distribution, we're just going to drop XO. And then we're going to create a heat map using Seaborn. And when we create the heat map, you can see that none of the columns are very highly correlated, so we're not going to worry about dropping highly correlated columns. But you can see core, and you can see the correlation between each of the columns. So now what we're going to do is we're going to use sklearn to standardize our data set. So there's a possibility that the data that we are working with has already been standardized. So what I might do when I finish this code review is I might go through and take out the standardization in another Jupyter notebook and see if that improves the score. And then we're also going to encode the label. So this is our label. So from sklearn import preprocessing, LE equals preprocessing dot label encoder, and target equals LE fit transform target. So we're going to define our X and our Y values. Those are your independent and dependent values. Y is your target, X is your train, and X test is your test. We're going to split the X and Y variables up into training and validation sets. So you can see that. Now what we're going to do is we're going to define our class weights. We're going to use sklearn to define the class weights and convert the class weights to a dictionary. And now what we're going to do is we're going to define a model, and we're going to use sklearn's random forest classifier. And we got 99% on that. We're going to use predict on the validation set, and we only got a 91% when we predicted on the validation set. We're going to create a confusion matrix, so you can see the confusion matrix, and you can see all of the correct predictions and all of the predictions that are not correct and what they should have been. We're going to create a histogram of the predictions, or widespread really. And then what we're going to do is we're going to define the importance. So we're going to find the features, importances. So you can see the features, importances in numeric values. And then we're going to define the names of the features, being from x1 to x7. And we're going to create a bar chart which will show you the feature importances. So you can see it looks like x3 has the highest feature importance, whereas x2, or maybe is it x5, has the lowest feature importance. Now we're going to predict on the test set, and then when we predict it on the X test set, we have to convert it back to alphabetic values, because that's what Kaggle wants to see when we submit our predictions. Kaggle wants to see letters. So we inverse transformed the label, and then we created a histogram of the predictions, and so you can see B is the highest level prediction, followed by A, C, then E, and then D. And then what we're going to do is we're going to prepare our submission. So submission column Y is going to be your prediction. We're going to convert it to a CSV file, and this is your CSV file. And this is what we have submitted to Kaggle. And when I submitted it to Kaggle, I got a 91.129. So that's it. That's it for your code review. And I've only got one thing to do to see if I can improve my score, is to remove the standardization and see, because there's a possibility, I don't know very much about this data set, but there is a possibility that it's already been standardized, and then if it's standardized a second time, then what is the output going to look like? So that's something that we can try, see if we can improve our score. So I'm going to go ahead and close this code review because I've covered everything in the code review. I will leave a link to the Jupyter notebook in the description box down below, so you can check it out yourself, see what you think about it. And so I would like to thank all of my subscribers for supporting my channel. If you like my video, please like, subscribe, and share. If you want to be notified whenever I make another video, please tap onto the bell button next to the subscribe button. And thank you for watching my code review. I look forward to making more code reviews for you in the future.